Hi everyone. In this video, we're going to learn how to solve equations with radicals in them. And the good news is that most of the steps of doing this are the same as solving any other equations. We can use the same thought process. So let's start off with the basics. If I take a look at level 1 equation A, and the square root of x equals 3. When you're solving an equation, no matter what it is, you should always ask yourself, how do I isolate the variable or get it alone? Which means I need to get rid of anything that's bothering the variable. So in this case, the square root is quote unquote bothering the variable. And how do I undo a square root? So I'm looking for an inverse operation. So like multiplication and division, they undo each other, they're inverse operations. And to undo a square root, I need to square it. And whatever I do to one side, I need to do the other. Just for a quick side note about why squaring a square root works, when you square something, it means you're multiplying it 2 times. So that's really square root of x times square root of x. And the square root of x times the square root of x, you can put under one radical, which is really the square root of x squared. And the square root of x squared is just x. So when I square that square root, they cancel each other out and you're just left with x. But this is the reason why. Anywho, so you'll get x equals 9. Okay? So you're always looking for what can I do to undo that operation. Now, let's take a look at this one. We do the same thing. We're going to square root both sides, square both sides. So you get x equals 9. Now, one nice thing about solving equations is you can always check your answers to see if they're right. So I can take x and plug it in and see if I get my original. So if I take the square root of 9, do I get 3? Yes, I do. Now here I plug it in and I take the square root of 9 and it's not, the square root of 9 equals negative 3. But really the square root of 9 equals positive 3. So this says 3 equals negative 3. Is that true or false? Okay, and in this case, obviously that is false. So sometimes when you're solving a radical equation, you're going to get something called an extraneous solution. Okay, what extraneous means is essentially a false solution. Now the reason you're going to get a false solution is because what you've done is you've squared the variable. So what you've really done is you've introduced a second solution. So in this problem, I'd really say that there's no solution. And if you think about it, it makes sense. There's nothing you could square root to get an output of negative 3. So you always, when you're solving radical equations, are going to need to check for false solutions, which are called extraneous solutions. We'll practice this as we continue through if you're not quite sure what I'm talking about yet. Okay, level 2 gets a little bit more complicated because you don't just have a basic square root, you've got some other stuff bothering it. And again, the good news is you solve this like you solve any other equation. So if I had the equation 16 equals 11 plus x minus 3, you'd move everything over by subtracting the 11, so on and so forth. All of those steps stay the same. You just have an extra step with a square root. So I would first subtract 11 from both sides and get 5 equals the square root of x minus 3. Okay, then to get x by itself, you're going to have to get rid of the radical. And how do you undo a square root? You square it, like we looked at above. Okay, so 5 squared is 25. Square and a square root undo each other. They cancel each other out. So you get 25 equals x minus 3. Now you just have one last step, and you get x equals 28. Okay, so again, I want to check that and make sure it's a true statement since I'm squaring a variable. When you square a variable, you're adding in another variable. So if I plug that in, I get 28 minus 3, which is 25. The square root of that is 5. 5 plus 11 is 16. So that will work. I've checked it to make sure it's not extraneous. General rule of thumb, when you're solving any equation, whether it's a radical equation, we kind of all know this, but I don't know if we think about it all the time. You always work in reverse PEMDAS when you're solving. So you first start with adding or subtracting things, which we did here. Then you would undo multiplication or division. Okay, then you take care of exponents, and then parentheses. So in this case, an exponent and a radical are very closely related. You can always write a radical as an exponent. So that's why you take care of that after the multiplication / addition subtraction. And then anything in the parentheses, really this is your thing in parentheses, which is why we added the 3 last. So a note to self, you always work in reverse order no matter what you're solving. Okay, I'm going to leave B for you to try on your own. Don't forget to check for extraneous solutions. Now, C is a little bit different because I have 2 variables or variables on either side of the equation. So I'm going to just kind of follow the same process I did here before, or I don't know. So I guess the goal is always to isolate the radical. Why do I want to do that? Some people might jump to squaring this right at first, but notice this is a binomial and there's two terms. So to square that, you'd have to do 4 plus square root of x plus 2 times 4 plus the square root of x plus 2, which is just not very pretty. So let's see what happens if I isolate the radical first. So in order to do that, this 4 is bothering the radical. I'd move it over. You can't combine x and minus 4, but I can write this as x minus 4 equals square root of x plus 2. Okay, now I know I still need to undo that radical. Since I didn't do it first, I've got to do it second. So let me square both sides here. The nice thing here is you don't have to FOIL out a radical. That square and that square root will just undo each other, so you'll be left with x plus 2 here. Now you will have to square this other side, but it's a little bit easier to square the x minus 4 times x minus 4 than it would be for the radical. Now, if I square that, I get x squared minus 4x would give me minus 8x. Minus 4 and minus 4 would give me plus 16. Okay. So again, you could have done it the other way, but you'd have to FOIL out a radical, and it's just not pretty, and it's going to be more complicated. So you always want to take my advice and isolate the radical. Now, notice what this has turned into. I've got a square term, which makes this a quadratic. And anytime you solve a quadratic, we want to use the zero product property and factor or use a quadratic formula. So this is a connection to our previous unit. Just a reminder, the reason why you want to set it equal to 0 is because when you solve for x, you're solving for x-intercepts. And the y-coordinate at any x-intercept is 0, which is why you want the whole equation to be set equal to 0. Anywho, so let's move everything over so we can get this set equal to 0. If I do that, I'll have x squared minus 9x plus 14 equals 0, which then you could try and factor, use the quadratic formula, and solve for your x. So I have x times x minus 7 times minus 2 will FOIL to be this here. You can double check that on your own. So my x values will be 2 or 7, which then you're going to need to check for extraneous solutions. So I'm actually going to show that work here. Let's do this together. I have 2 equals 4 plus 2 plus 2. So that would say 2 equals 4 plus the square root of 4, which 2 equals 4 plus 2. Uh-oh, is that true? 2 equals 6? No, it's not. So this 2 is not going to be a solution. It is going to be a solution, but it's an extraneous solution, which means it's a false solution. Now let's try it for the 7. So I have 7 equals 4 plus square root of 7 plus 2. Okay, so 7 equals 4 plus 9, square root of 9. 7 equals 4 plus 3, which is true. 7 equals 7. So that means my only real solution is x equals 7. Again, extraneous solutions will show up frequently because you're squaring the variable. So you need to check and make sure that all your solutions are true, which is just a good skill of solving in general, is that you can check your answers. But in this case, you should get some false ones. Not always, but often. Okay, now level 3 is another example where there's multiple variables. But this is a step up because there are multiple variables under a radical. So here's my advice. You should never have two radicals on one side. Because again, if you want to square this, you got to square the whole thing. And you're going to have to FOIL this ugly, ugly thing of x plus 9 plus x times square root of x plus 9 plus the square root of x. It's just not going to be fun to FOIL. So instead of having two radicals on one side, I would get one on either side. So what I would do is I would make this the square root of x plus 9 equals 9 minus the square root of x. Now, you're still going to have to square both sides. So I would square this, and I would square this whole side. And you're going to have to FOIL something that's not super nice, but it's going to be nicer than having two radicals. Okay, so in these problems in level 2, you could isolate the radical. In these ones, since there are two, you can't really isolate it, so you just have to get one on either side. One radical per side. I want you guys to practice your simplifying skills, so all I want you to do is square this, and I'll come back with the answer. No cheating, no looking. If you FOILed correctly, I showed all my steps here, so I just expanded it to multiply 2 times. Then I did my first, outer, inner, last, combine like terms. So if I have minus 9 root x and I subtract 9 more root x's, I have minus 18 root x. And this is what it should look like simplified. Now I know they're still radical, but now this is an equation with only one radical, which is going to be a lot more similar to our level 1, level 2 problems. So you're going to have to go through the process again. Let's isolate the radical, get everything else on the opposite side. So I'll subtract the x's here. Ooh, that's nice, they cancel. I'll also subtract the 81. So I'll get negative 72 equals, these have canceled, so I have negative 18 square root of x. Again, you're going to take care of the radical after you take care of any addition, subtraction, or multiplication or division. So this is negative 18 times the square root of x. You can divide both sides by negative 18. If I multiply by 18 and divide by 18, those will cancel. And then negative 72 divided by negative 18 is going to give me positive 4. So I'll have positive 4 equals the square root of x. And finally, I can get rid of this radical, square both sides, and I'll get 16 equals x, which you can go ahead and plug in here to make sure you got the correct thing. So 16 plus 9 is actually 25. The square root of 25 is 5. Square root of 16 is 4. So I have 5 plus 4 equals 9, and that does work. Okay, so moral of the story, you use all the same solving strategies that you would for any other solving problem. You just have to worry about the radicals. So the goal is, ideally you'd only have one radical, and then you just want to isolate the radical. Or if you have multiple radicals, get one on either side. Those are the key pieces of information that are new. If you have any questions, please bring them to class. Otherwise, have a great rest of your night.